All right, so we're going to repeat a process that we learned in grade 11, which was how do we find exact values of angles that are greater than 90 degrees? So they fall in quadrants 2, 3, and 4. And we're going to do this in radians. And what we're going to use for this is we're going to use the special triangles that we reviewed in our last lesson, so special triangles with radians. And we're also going to use this unit circle that we filled out in our previous lesson where we identified where all of these radian values were. So here's the steps here. We have 4 main steps. The first step is going to be to place the angle in the correct quadrant. So I'm going to sort of recap maybe some of the stuff that we talked about in that first lesson. If I have 5 pi over 6, the reference angle that I want to look at is pi over 6, and that is equivalent to 30 degrees in degree value. Pi over 6 is 30 degrees, right? And we talked about with the pi over 6s, as we go up by 30 degrees, I have 0, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and this would be 6 pi over 6, because we know this is pi, right? So if I counted up by pi over 6s, I would find that I have 5 pi over 6 over in this location right here. That's what I'm interested in. I don't really need, I just wanted to show you the counting process, but I don't really need these other things here. I'm interested in 5 pi over 6. And so now I've placed the angle in the correct quadrant. 5 pi over 6, another way that you can also place this is you could switch 5 pi over 6 into degrees, and then maybe you can think about it in terms of degrees, just for placing it properly. So it'd be equivalent to 150 degrees. Form the triangle and the reference angle. So we always form the triangle. So do I form my triangle this way, or do I form my triangle this way? Which is the correct option, red or green? Red. We always form the right angle triangle with the horizontal line. Okay, so you're going to make your right triangle with that horizontal there. And the reference angle, so when we worked in degrees, we actually had to do some subtracting and things like that to figure out what the reference angle was. In radians, it's really easy. This is the reference angle right here. It's pi over 6. That's the angle in this little corner right here. Okay, so this is pi over 6. And of course, if I have 90 and I have pi over 6, I'm dealing with the 30, 60, 90 triangle, or in radians, I'm dealing with the pi over 3, pi over 6, pi over 2 triangle, right? So I can fill in the last spot here. This one will be pi over 3. Okay, so we formed the triangle and we labeled the reference angle. Now we are going to calculate the ratio using the special triangles, and we're going to kind of do these at the same time. We're going to use the cast rule to determine the sign of the answer as well. So we'll do a little recap of cast rule as we're doing this. Okay, so the sides of this triangle, 1 always goes across from the smallest angle. So across from pi over 6 is 1. Across from pi over 3 is root 3. And the hypotenuse of the pi over 3, pi over 6, pi over 2 triangle is 2. I'm interested in sign. So I'm interested in, based on this as my reference angle, pi over 6, I'm interested in opposite and hypotenuse. This is opposite. This is hypotenuse. So this should be equal to the same thing as the sign of pi over 6, but I also have to use the cast rule to determine whether it's positive or negative. Remind me what the cast rule tells us. Who remembers this from last year? How does the cast rule help us? Serena?
Like basically if it's in like that quadrant, so if it's in like S, then it'll be positive, or if it's also in I think A, then it'll also be positive because that's like all of them.
Yep.
But if it's like in the other quadrants where it's not like the same letter, then it'll be negative.
Yeah, so S tells us that sign in this quadrant is positive. Sign is positive here. Cos and tan are negative in that quadrant. So if I'm taking the sign of an angle in the sine quadrant, I should expect my answer to be positive because I'm in the sine quadrant. So this should be equal to the positive sine of pi over 6. right? Whatever that is. Usually I don't put this, but just for our purposes right now to think about how we're using cast rule, I'm going to put positive in front. So the positive sign of pi over 6, opposite over hypotenuse, that's positive 1 over 2. And that should be our answer. Okay, so that's our last 2 steps there. So same as last year, except with radians instead of with degrees. Okay? Probably the bigger challenge with, like, obviously we're reminding ourselves of some of these steps, but maybe the bigger grade 12 kind of thinking here is, where do I place something like 7 pi over 4, right? Or where do I place something like 5 pi over 6? So that's more the radian part of this. Okay, so let's try another one. Cosecant, this is a reciprocal ratio of 7 pi over 4. So if we count up by pi over 4s are like 45s, right? The pi over 4s, if I split the top section into 4 pi's, okay, this will be 0, this will be 1 pi over 4, this will be 2 pi over 4, 3 pi over 4, 4 pi over 4, which of course reduces to pi. And then if I split the next one into 4 equal slices, this will be 5 pi over 4, 6 pi over 4, and there's 7 pi over 4. So this is the one that I want, right? So just sort of reminding you of some of the stuff that we did earlier this week. So I don't need all of these, obviously. I just need the 7 pi over 4. That's what we're interested in. So there it is. I will create the right angle triangle now. So we place the quadrant, placed it in the correct quadrant. We're going to form the triangle and label our reference angle. So triangle always gets formed with the closest horizontal. So create a right angle triangle here. The reference angle is always this interior angle. So our reference angle is pi over 4. So I'm going to use the isosceles triangle, right? I'm going to use the pi over 4, pi over 4, pi over 2 triangle. So we can label this and label our sides based on our ratios that we talked about in the last lesson. So 1, 1, and root 2 for the hypotenuse. Okay, we formed our triangle. We have our reference angle. We have located the ratio, the triangle side lengths. Cast rule, C-A-S-T. So cast rule, starting with the bottom right quadrant, you spell the word cast, going counterclockwise. We need to know cosecant. What is its primary trig ratio? So cosecant is the reciprocal of either sine, cos, or tan. Which one is it the reciprocal of, Bella? It's the reciprocal of sine. So cosecant is going to be positive where sine is positive and negative where sine is negative. So we're in the cosine quadrant. Is sine positive or negative in the cosine quadrant? So cosecant must also be negative in the cosine quadrant. So this is going to be equal to the negative cosecant of the reference angle, and of course this is our reference angle right here, cosecant of pi over 4. So if cosecant is the reciprocal of sine, and sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. So I'm interested in, based on this as my reference angle, this will be opposite, and this will be hypotenuse. And so I will get negative hypotenuse over opposite. So negative root 2 over 1. This can just simplify to negative root 2. So there's our solution. Okay, you'll probably notice that a lot of things in this unit are just repeats of some of the concepts that we covered in grade 11, but just in radians instead of in degrees. Can I clarify any questions on these? Okay, why don't you guys try this guy? See if you can follow along with the steps. We want to place 11 pi over 6, create the triangle, use the cast rule, all of that good stuff. I'll give you a couple seconds head start on this. All right, so when I see a pi over 6 reference angle or a pi over 3 reference angle, those come from counting pi over 6s. So the easiest way that you can place this is split the top part up into 6 equal slices. So 1, 2, 3, 1, 2, 3, 6 slices on top, and same thing on the bottom, 6 slices on the bottom. So 1, 2, 3, 1, 2, 3. Then count up to 11 pi over 6. So this is 0, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4, 5, 6, 7, 8, 9, 10, 11. This is 11 pi over 6 right there. Okay, so 6 equal slices on top, 6 equal slices on bottom, count around to 11, you have 11 pi over 6. That's it. Okay, if I do 4s, then I split the top into 4s, I split the bottom into 4s, and then I count around to the number that I need. Okay? All right, so I don't need all of these. So there's my 11 pi over 6. I create the right angle triangle with the closest horizontal. So make your right triangle. The interior angle is the reference angle here, pi over 6. Okay, that makes this pi over 3. And that makes the side lengths 1, root 3, and 2. This is the reference angle that I'm going to use to label opposite, adjacent, hypotenuse. Okay, Zach? So this is the pi over 6, pi over 3, pi over 2 triangle. So we reviewed in our last lesson the special triangles. So we know that any angles inside a triangle, if we're talking about degrees, they have to add to 180. In radians, the equivalent to 180 is pi. So if you weren't sure what this was, I would need the angle of pi over 6, and we have a right angle, which is pi over 2, plus some other angle, we'll call it angle A. That all needs to add up to 180 degrees, which is pi radians. So by default, this one has to be pi over 3, because that all would add up to pi. Rebecca? I mean, not really, but we are filling out the special triangle, so, I mean, you could not put it, but I don't know. I'm filling out all the information in there, so I just put it. Okay, 2 more elements that I need here. I need the opposite, adjacent, hypotenuse side so that I can find tan of my angle. So based on pi over 6 as our reference angle, this is opposite, and this one is adjacent. That's what we need for tan. And then I need cast rule. So cast, what does this tell me based on our question here? Okay, so tan of 11 pi over 6 must be equivalent to the negative tan of pi over 6. And so my answer will be negative opposite over adjacent, so negative 1 over root 3. If you typed this into your calculator, and if you have a calculator that leaves things in exact value, you would notice that you got a slightly different answer to this. Did anyone try typing it into their calculator who has an exact value calculator? So you would actually get negative root 3 over 3 if your calculator is one of those ones that leaves things in like fraction and radical form. And the reason for that is that your calculator would rationalize that denominator for you. Okay, so it would come in and it would multiply the top and bottom by root 3, and then you'd get negative root 3 over 3. I'm fine if we leave it at negative 1 over root 3 for these quick types of questions where we're just evaluating like a single value. That's fine. Okay? Okay, secant of 3 pi over 4. I'm going to give you guys a couple of seconds head start on this one. Okay. All right, so here's our 3 pi over 4 angle right here, as I had before. Secant is the reciprocal of cosine. So if we're in the sine quadrant, cos is negative here. which would also make secant negative. Okay? So cosecant, reciprocal of sine, secant, reciprocal of cosine, cotangent, reciprocal of tan. So secant is the reciprocal of cos. I made it negative due to the cast rule. And then because it's the reciprocal of cos, if cos is adjacent over hypotenuse, secant is hypotenuse over adjacent. So here, my hypotenuse and my adjacent were root 2 and 1. And then I simplified to give me negative root 2. Keaton?
So I thought, like, if it's the reciprocal of cos, I thought it would be like negative, or it would be positive where cos is negative.
So it's not the negative reciprocal of cos, it's just the reciprocal. So when we just do a reciprocal, we just flip the fraction, we don't switch the sign.
Okay, so, but, like, I didn't know where positive.
So the cast rule tells us, so all ratios are positive in that quadrant, including the reciprocal ratios. In the S quadrant, sine is positive, but cos and tan are negative. And that means that their reciprocals will also be positive and negative where they are positive and negative. Does that make sense?
Yeah.
Okay. Any other questions on this one? Okay, so the goal of the next one is we want to find sine, cos, tan, cosecant, secant, cotangent of 5 pi over 3. So same sort of process, except instead of just finding one of these, we're finding all of them. So use the cast rule, use your special triangle, place the angle, all that good stuff. Okay, I'm going to give you a little head start on this one as well. Okay, so I placed my angle, I created my triangle with the closest horizontal line. Pi over 3 is the reference angle. That goes in that interior corner there, which makes this 1, root 3, and 2. And then adjacent, opposite, and hypotenuse, like I've labeled here. I also labeled the cast rule, and because we're in the cosine quadrant, cosine and secant should be positive here. Sine, tan, cosecant, and cotangent will all be negative. Okay, so now I'm just setting up the positives and negatives and opposite, adjacent, hypotenuse. So tan opposite over adjacent should be root 3 over 1, and it's negative. And then for the reciprocals, it's a lot less work for the reciprocals because if I already have the primary ones, I'll just flip them. So this will be negative 2 over root 3. This one will be 2 over 1, which will simplify to 2. And then cotangent will be negative 1 over root 3. Just flipping this here. So there are all of our ratios for 5 pi over 3. Can I clarify anything here or answer any questions? Zach? Okay, so did you get the placement part?
Yeah, that part's fine. It's all the right stuff.
Okay, so let's just redraw this here quickly. So we've placed the angle. We wanted to think about this as 10 pi over 6, right? So we counted up 6 slices on top, 6 on the bottom, counted around to 10 pi over 6. That reduces to 5 pi over 3. Pi over 3 is the reference angle, okay? So this is what will always be in this interior corner here when I make my triangle with the closest horizontal. So we're going to create always a triangle with the closest horizontal to our angle. We never use the vertical lines to create our triangle, always the horizontals. So I'm making a right angle triangle here. And because pi over 3 is the reference angle, pi over 3 is actually in this interior corner here. Okay? So we are using the pi over 3, pi over 2, pi over 6 triangle, the special triangles from our previous lesson and from grade 11, but we just did them in degrees in grade 11. So if that interior corner is pi over 3, the other corner has to be pi over 6. Okay? I'm going to label the side ratios based on our special triangle side ratios. So across from pi over 6 is always 1. Across from pi over 3 is always root 3. And the hypotenuse of this triangle is always 2. Those ratios will always be the same for the special triangles. Okay, there's only 2 special triangles, just this one and the pi over 4 one. Okay, So our reference angle, as I mentioned before, is pi over 3. That's how we're going to label opposite, adjacent, hypotenuse. So opposite to pi over 3 must be root 3. Adjacent is the other leg of the triangle. That's not the hypotenuse. And hypotenuse is, of course, across from the right angle. From there, I'm just using SOHCAHTOA to set up opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. And I'm using the cast rule to decide which of these will be positives and which of these will be negatives. So because we're in the cosine quadrant, cosine and secant have to be positive, cosine and its reciprocal ratio. The rest of the ratios are negative. So sine and cosecant, I wrote those as negatives, and tangent and cotangent, I wrote those as negatives. Cosine and secant, I wrote those as positives. And then we're just doing opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. And then we're flipping them for the reciprocal ratios. Bella? Sorry, ask that one more time. Yep. That's fine as long as I can see your supporting work. I would expect to see like a supporting picture or something, because I know that your calculator can just, most of the calculators will just spit out the answer to this. So I would want to at least see this and maybe like a note as to how you know which ones are positive and negative. But yeah, if you don't want to do this in between step, that's fine. Amelia. Yep, so let's, maybe I'll just do that below quickly here. Okay, so 5 pi over 3 is equivalent to 10 pi over 6. And so if you take this top half up here and you split it into 6 equal slices, 1, 2, 3, 4, 5, 6, and then again, same thing on the bottom, split it into 6 equal slices, so 1, 2, 3, 4, 5, 6, and then we're just going to count around to get to 10 pi over 6. So this. Yeah. The 5 pi over 3 comes from 10 pi over 6. So I can't tell you that there's specific lines for pi over 3s because it comes from the pi over 6, counting around from pi over 6s. So you have to, whenever you see pi over 3s, you have to express it as a pi over 6 so that you can count around to get to that location. Yeah. The other option is you can switch. We practiced in our last lesson switching from radian mode to degree mode. So you could switch from radians into degrees just to get your placement, and then you can work in radians again. Nope. Okay, last question, guys. This is an application. So Nicole is flying a kite at the end of a 50-meter string. The sun is directly overhead, and the string makes an angle of pi over 6 with the ground. The wind speed increases, and the kite flies higher until the string makes an angle of pi over 3 with the ground. Determine an exact expression for the horizontal distance between the two positions of the kite along the ground, so the horizontal distance. Okay, which angle is bigger, pi over 3 or pi over 6? Pi over 3 is a bigger angle, right? You could even calculate the decimal value if you wanted to. If I take pi and I divide it by 6, it's going to be a smaller number than if I take pi and divide it by 3. Pi over 6 is 30 degrees. Pi over 3 is 60 degrees. So this is the bigger angle. Keep that in mind as you're thinking about your drawing. Okay, so we have a kite string. Here's the ground. We've got a kite string. Let's say it's being let out from here. And the wind speed is kind of low, so the kite is kind of low to the ground. Let's say it's like something like this, right? And actually, we might as well just go up to this. So here's our kite. This is the first position. This is 50 meters. Okay, and we know that the kite string makes an angle of pi over 6 with the ground. Then the wind speed increases. Okay, and now the kite is going to go higher into the air. The kite goes, you guys might not want to draw your drawing as big as I'm drawing mine, but the wind speed increases and the kite goes higher into the air. The kite string is still 50 meters. It hasn't changed. But now the angle that this makes with the ground is pi over 3, the whole angle there. If I were to create sort of like a right angle triangle out of these lines here, I have one right angle triangle here, and I have another right angle triangle right here, right? I'm interested in the distance along the ground, the horizontal distance between this position of the kite and this position of the kite. This is the goal. We're going to call that x. In order to find x, I'm going to use the black triangle. I'm going to find this length. We'll call that y for right now. And I'm going to use the blue triangle, and I'm going to find this length. If I find those two lengths, what's the relationship between x, y, and z? How do I find x? X equals what? Y minus z. So that is the ultimate goal here. We're going to find what is y minus z. Okay, so let's just look at these two triangles. Sometimes it's nice to just separate these out into their own triangles, right? I'm going to look at triangle number 1, the black triangle, for a second. And the black triangle has a 50-meter hypotenuse. It has pi over 6 here, and we labeled this side as y. This is what I want to know, right? Y is my question mark here. So if I know pi over 6, and I have adjacent, and I have hypotenuse, which trig ratio am I going to use to help me find y? Cos. Cosine is adjacent over hypotenuse, so I'm going to use cos. So let's set up an expression. Cos of theta is always equal to adjacent over hypotenuse, and I know theta is pi over 6, and I know adjacent is represented by the variable y, and I know hypotenuse is 50. So it might also be helpful for us to have our special triangle labeled as well. So if I have a pi over 6, pi over 3 triangle, the side ratios are 1, root 3, and 2. You need to know this, okay? We're going to be working with these special triangles a lot. Same way that we knew the 30, 60, 90 triangle was 1, root 3, and 2. Now we know that the pi over 6, pi over 3, pi over 2 triangle is 1, root 3, and 2. Same thing. Yep.
Why can't you just fill the black triangle in like that?
Because the hypotenuse is 50 of this. This is a scaled up version
Wouldn't
of.
the top angle still be pi over 3?
Yep, it is. The angles are the same. The side ratios are scaled up. Yep. Clayton?
Could you just say like 50 divided by 2 is 25, so multiply with it?
Yep. So that would be a way that we can use as well. So Clayton is suggesting, can we use scale factors for this? I think is what you're saying. So if I find the scale factor from 2 to 50, what do I need to multiply 2 by to get 50? 25. The scale factor will be the same as the related side for y as well. So if I take root 3 and I multiply it by 25, I'll have y. I can also do it by setting up an equation. So if I were to set up an equation and put in the ratio for adjacent and hypotenuse of cosine, I can actually plug this right in. Cos of pi over 6 is just root 3 over 2. And then I can just isolate for y by multiplying up the 50. And it should reduce to 25 pi either, or 25 root 3 either way. Okay, so I would get 50 root 3 over 2, and then 50 divided by 2 is 25. Okay, so whether you want to use scale factors or whether you want to plug it into an equation and sub in the exact value, basically we're just replacing cos of pi over 6 with its exact value from the special triangle. That's the goal. Okay, so there's our first measurement. Y is 25 root 3 meters. Second triangle, let's separate this out. We're going to do the blue triangle below. Okay, so second triangle, blue triangle, is the pi over 3 measurement here. This was still 50 meters, and we wanted to know this Z value. So if we want to go along with the idea of scale factors, it might be helpful to just sort of redraw our special triangle in the same format that we see here. If you can do it with the other one, that's great too. And I think my pen stopped working here. Give me 2 seconds. So if I were to sort of draw the smallest scale version of this triangle, this is 1, root 3, and 2. So if we just sort of observe here, 2, we already said 2 times 25 is 50. And the side I'm looking for relates to the side of 1 from our special triangle. So what is Z going to be equal to if I take this and scale it up by a factor of 25? Just 25 meters. 1 times 25 is 25. Okay, notice that I put the pi over 3's in the same location so that I could sort of see the correct sides that match up with the correct sides of our original triangle. Okay, so we said, so the last step here is we said that x was equal to y minus z. And we just found y and z to be 25 root 3 meters minus 25 meters. And probably the way that we're going to express this is just common factor out the 25, just to have this as a simplified value here. So if I take out the 25, I'm left with root 3 and 1 here. If you gave me this answer, that would be fine. But in your worksheets, you're probably going to see that the common value is common factored out. And you'll probably see that in the textbook as well. So just wanted to make you aware. If you see that, it's kind of the same. It's the same thing, but common factored. Okay, so exact value questions would be a no calculator question. They would be, you should be able to do it without a calculator, and you should be using the special triangles to either use scale factors, or you can replace the value like we did with cos of pi over 6. You can replace it with its exact value and then just isolate for the value you need. Okay. Is our break at 11 today?
Did you
Yeah.
say that it would be okay if we gave you the 25?
That would be fine, yes. Yep. Just want to make you aware of that because I think you'll see it common factored in your worksheets and textbook and stuff like that.